So this is actually coming from section 8.3 in the book. It's the one piece of this chapter on matrices that's relevant to what we're doing here. But again, you can use this for solving any time we get a system of equations, so it might be useful. So here's the first thing. If I'm going to solve this system, right, that's 3 equations and 3 variables. The first step is to write it as a matrix equation. And by a matrix, we mean a rectangular array of numbers, usually in square brackets like this. So notice where these numbers come from. The 2, 3, 1 are the coefficients, 2, 3, 1, right? 3, 3, 1, 3, 3, 1, 2, 4, 1, 2, 4, 1, right? That first matrix is always a square matrix, the same number of rows and columns. And it's just the coefficients in that order, right? Don't write it as 2, 3, 1. Don't write that down like that, right? It goes exactly like it looks there. The next matrix is the variable matrix. It's the things we're trying to solve for, X, Y, and Z. And then the next matrix on the other side of the equal sign, it's these numbers here. That's the constant matrix. Okay. Now, we would consider this matrix is a 3 by 3 matrix because it's got 3 rows and 3 columns. This is a 3 by 1 matrix. This is a 3 by 1 matrix. And you don't have to understand this right now, but when you multiply matrices, the way you do it is you multiply across the rows and down the columns. 2x plus 3y plus z equals -1. 3x plus 3y plus z equals 1. 2x plus 4y plus z equals -2. Exactly what these 3 say. So if you understand how matrix multiplication works, this says the same thing as this. Okay. So what we're gonna do is we're gonna store these matrices, this matrix here and this matrix here, in the calculator, which is what this is going to show us how to do. And then we are going to do this operation in the calculator. Matrix A to the -1, matrix B. And that will solve our equation. So, for example, let's get your calculators out and try this.